Hey everybody, Zachariah J here. Welcome to my little lab in my garage, my workstation. This video is going to be a head-to-head print challenge between the Phenom made by Peopoly and the T1000 made by G3D. So I've already obviously shot all of the clips that I'm going to be going through. This is going to be a really long video. It's probably going to be an hour and a half video. But I go into some really deep evaluations of some of the parts on both of the machines and comparing them, and also my experience with both of the companies. Actually, I haven't actually had to contact Peopoly directly, but I have worked through with Matter Hackers, so big shout out to those guys. Those guys have been great. The customer service at G3D has been awesome, so shout out to Ray, who I've been in contact, and also the guys over in the Philippines where I think the machine's made. So, and I think in the video later I say Indonesia, but it's actually the Philippines, so sorry about that. But anyway, without further ado, let's get into some of the bits and bobs about the machines and how to put the slicing of the machines, or not the machines, but the files, and getting the files in here, and then printing them, and then what do those prints look like, and all of that kind of stuff. So let's get after it, all right? You can see here I've got some parts here on the surface. This is set up for the Phenom. So you can see it has quite a lot of parts on here. I'm fully covering the build plate. And one thing that I really like, well, there's several things I really like about the Phenom, but they don't try and control the proprietary slicing software. They're just like, you know what, other people can focus on that. They do a really good job. And the people at Peopoly are focusing on making a really good machine. So I actually get to do all of the things I want to do for setting up my print job all in one program. So I get to put, you know, all my parts on the build plate. I can do all of my supports here. I can adjust any of the features about the supports, add the supports, and then come back and I can actually slice. The other thing that I like about this is, actually it's in here, I can pick my resins and I can set up all the profiles for all these different types of resins. So you can see I've even got one of them here at least, that is not on the Phenom's list of approved resins or resins that they've tested. I actually tested this Lacrete X Strong and it actually worked really well. But you can pick whichever, like I'm going to be using the Siraya Tech Fast, so I click that and I can put in the costs. It does do a cost analysis for you. You can control all of your settings right here. If you have parts that you want to hollow out, you can do an infill here. So you really have a lot of control over the profiles. So once you get your supports, everything's all set up, you just click slice. It's actually trying to hollow some of these pieces because I checked the infill part. I really don't need that, but the slicing part takes quite a bit of time, especially if it's a part that is, you know, 200, 300 millimeters tall. So we'll just wait for this to finish. All right, there you go. Since I put in the price of the resin, it'll calculate how much this print's going to cost in resin. So it's about $6. Tells me the volume of resin that I'm going to end up using. Also tells me which machine. I didn't set up the name of the machine. I could change that. The resin that I selected and how long the build time is estimated to be. This is about a 5.5 hour build. And then it reminds you of all of your settings so you can come back and confirm that you did in fact put in the correct settings. The other thing that's great about ChichaBox is you can also just move these sliders and see which each individual slice is going to end up looking like. And it looks like, since I did that infill bit, it hollowed out the handle here and it put a little cross section in there for support to make sure it doesn't collapse on itself, or, you know, because the wall thickness is set at, I believe, at 2.5 millimeters. It would be really easy to flex it and close it or squish it. So it's got all these little infill bits in there, which is pretty cool. But if you wanted to, you could come back and look to make sure if there's weird overhangs or whatever, and make sure that every one of those little islands gets caught by a piece of support, so it doesn't fail. There's another program out there that you can actually put in and evaluate the supports, because I used auto supports on this, and make sure that everything's good. But anyway, that's a whole nother thing. If we look, I can go ahead and save this out, and then that would be the file that I would print from. Now I've already saved this one out, so I don't need to do that on this one. So I'll go back. Now I'll show you the process that I end up having to use for the T1000. Now I've already got all these parts on here. I'm just going to change my setting here to T1000, and boom, you already see how much more build volume you get out of the Phenom. I can't fit nearly all of these pieces here, so I'm going to try and figure out a way to that looks like it'll fit. And then let's see, let's get this guy. This guy's not going to fit. This guy's not going to fit. These are not going to fit. Let's see if I can maneuver a couple of these pieces around and maybe get this last part here to fit somewhere. So I have 1, 2, 3, 4 parts that are not going to fit on this build plate. So right there you see a huge advantage that Phenom has, the Peopoly has, over the G3D printer, the T1000. So anyway, I'm pretty happy with that. Again, I'm trying to maximize the build volume of the build plate, so we'll be able to compare how well one does against the other at kind of like maximum build plate volume. I'm not maxing out the vertical axis, obviously, because that's just, I mean, if it prints this high, it's going to print the rest of the distance. So I can't use the slice tool for the T1000. I have to go here and save as, and then I have to save it as and I'm going to put it in my T1000 folder. And I have Mando here. I think I already did it. Yeah. So these are Mandalorian parts for the blaster and the wrist guards or hand guards or whatever. So I've already saved this out earlier just to save some time, but I end up having to save this as an STL. Then I have to close this, and then I have to open up the proprietary software for the T1000. Now when I get in here, then I have to open or add the model that I had for this, which put it in this guy, and then it'll drop it in, and there you go. Now there is some ability to add support structures in here, but if they're individual, there's no auto add. If I want to rotate these things, they have these really clunky tools on how it's used. You can't, it's not nearly as precise as what you can do with Chichibox. But anyway, I have to bring it into here. Now, once I drop it into here, I have to save yet another file. I have to save this as a G3L file. And we'll call this Mando 2 again, because this is the second plateful as far as when I do it with the Phenom. So once you've saved this guy, then you can go, oh, this is where you can change your pixel size and all of that kind of stuff, which that'll be another part of the video that we talk about the pixel size, so more on that later. Now you go to slice and it disappears everything. You choose this G3L file, which you just saved, and then you bring this up. Now you can choose the layer thickness, and I'm going to try and choose something fairly close. I'm going to choose the 52.5 because that is the layer thickness. The layer thickness of the Phenom was 50. So I'm going to pick the closest one, which is 52.5. I guess I could go down a little bit smaller, but we'll give it the benefit of the doubt here. We'll do 52.5. And then you can slice it. But I've also noticed that if you do that, it just resaves it the same name, and then you can get kind of lost in what the file names are and blah, blah, blah. So I actually like to, after it, put an underscore, and I put the pixel size, 175, and I also put the layer height, which I can't do 52.5, so I'll just put 53, rounding that 5 up. So I have the pixel size and then the layer thickness in the nomenclature of the file name. Then you hit slice on this guy, and it asks you, okay, where do you want to save it? Well, I'm going to save it the same thing, but now it's going to change it to a file extension of G3D. Save. And then it's going to slice the job, and this will take equally long as the Phenom does. But you can start to see how clunky it is to use the proprietary software of the G3D system versus just using ChichoBox straight out and using that as your slicing tool to send your files. All right, so there you go. Our job's done here. Blink. And we can kill this now. And I have to use Google Chrome. I know a lot of people love Google Chrome. I'm still a Firefox guy. Call me crazy. Here is one of the areas that actually I do like about the G3D is the Wi-Fi connectivity. Now it does have pluses and minuses to it as well, but it's really nice to just sit here at the computer and then I can just call up my G3D setup in a web browser. It's optimized for Chrome, so that's why I'm using Chrome. There are some weird issues, like if you go choose a file, you can't do this if you use Firefox. It's locked over here and you can't see the end of your file name. I do think it's kind of clunky that their web interface, look at all this real estate I have here. Why can't they just make this wider so I can see the full file name of everything? And it's not like I'm making my file names longer than they designed. You can see in here, there's this is a test file for Focus. Their file name is also very long. So most of these are all the test files. There's a few of them in here, like this camera lid. That's one I did. But anyway, you get in here, and I need to add a new file because my file's not in that list. Go to machine files. We're doing the T1000. We are doing Mendo, and there is the file that I just sliced just a moment ago. So now I open this file. And I come to my resident selection. Now here is another area where I think that it's a little bit of a disconnect between the process or the workflow that you have with the Phenom versus the T1000. When you do your slicing in the T1000, it slices it and it embeds all of the settings that you're using, your layer thickness, your cure times, all of that kind of stuff is all in that ChichoBox file. Whereas when you slice it with the G1000 or the T1000 rather, you're just doing the layers at that thickness. That's the only thing it controls. Now you come in here and now you're going to pick your resin. I'm going to use tough resin. This is obviously the large surface area. This is another area where there's no real instructions. It just says, oh, what's your print surface size? Well, large is the whole thing. Medium, where that line between medium and large is, I don't know. It's just your judgment call. There's no, and same thing between medium and small. So you're just kind of guessing at this point. Now they have built into the software the cure times for your initial layers, how many they are, and your cure times. In the past, I've had issues where it hasn't quite stuck to the build plate, and you have to go in and fiddle and figure this out, which if you're going to be using their proprietary resin with their software, you would think that their settings would be correct. But when I've been on tech support, which is great by the way, they get back to you very quickly and they'll talk you through anything. You have to have WhatsApp though, because you're usually talking to somebody in Indonesia, which is where they make the machine. But you end up having to raise these to get it to stick better or whatever. So I think that's kind of a little bit weird. Also does put the estimated time up here. This one's going to take 3 hours and 26 minutes based on these settings. And at this point, you would position the build plate. Now, before I do that, I need to go make sure I put resin in the tank, so when the build plate comes down, it is ready to go. So I'm going to leave this here just like this, and then you won't end up seeing me do this, but you position the build plate. When it gets down to the bottom, you hit start. So we'll move back over to the machines, and you'll see me set up the jobs on both machines and get them printing. And then after they're printed, we'll evaluate what the parts look like, and we'll go from there. Okay, here I am back at the machines, and it's time for us to put some resin in and get our print files going. But before I do that, I want to show a couple differences about the build plate and the ball screw mechanism and the vats of these two machines. So here we've got our T1000. Full disclosure here, this is my third T1000. This being the third is, I mean, the plus is the customer service of G3D system is excellent. I had a problem with my first machine. They immediately shipped me out another machine so I could get up and printing. COVID virus thing all happened, and I was printing away, and then I had an issue where the coupling unit between the stepper motor for the Z-axis and the ball screw separated and broke. I ordered another coupling piece, I installed it, and the machine was then still, this was wobbling, so it wasn't printing correctly. They sent me a third machine to replace and fix that problem. So they're really good about honoring their warranties, all of that kind of stuff. However, that did lead me into an investigation of what was going on with the machine and starting to evaluate some of their engineering choices of how they've set up the machine to actually print product. So let's take a step back from the that part and just look at the build plate itself. It's got a front screw. The screw, I believe, is some sort of stainless steel. Keep that in your mind, stainless steel. Here's the build plate itself. It's quite small. I mean, it's bigger than like the Mars machine and some of those, but comparatively speaking to the Theopoly machine, you can see a huge difference in footprint. I'm going to put this back in here because it does have some resin still on it from my last print. This one's somewhat clean. But the main thing that I want you to see is this is a very soft aluminum. I don't think it's 6061. Maybe it is. Even if it was 6061, it would be pretty soft anyway. And it has this small key feature, and I don't know if you can see it here, but this is the key feature that mates here. I've seen other machines do this. It's fine as long as it's a material that's not going to scratch or abrade away or over time kind of erode in a way. I noticed with my first machine when I tried to put the part on one time, and then when I pulled it off, it kind of was cockeyed and it put a scratch down the thing, and then from then on, it was just a nightmare to get the build plate on and off of that key feature because the material is so soft. It's really easy to, make it, for lack of a better term, boogered up, so it's hard to get on and off. And then once that happens, you are perpetually hurting the product or hurting the mechanism going on and off because it's constantly interfering with itself, and so it's just going to start scratching and abrading away and getting worse and worse. Similar to if you cross-thread a screw going into a nut, if you get it cross-threaded and you force it to go in, you're ruining all of those threads all the way in, and then forever that nut and screw are just messed up. Which brings me back to this being stainless steel. and what it screws into is aluminum. Best engineering practices would dictate that if you're going to have a mechanism that is screwed together and unscrewed and screwed together and unscrewed and screwed together over and over and over, you would want those two interfacing features to be of a material that are not going to be soft and erode over time with use. If it was just screwed together once and intended to only stay that way, you could probably get away with some cheap aluminum mechanism. But in this case, this is the build plate. It's how you get your print in and out. You're going to be taking this on and off every single time you print. So the likelihood of over time of it getting cross-threaded or the threads on the aluminum part to degrade to the point where it will no longer hold the thread is pretty high. I mean, of course, you would have to print a lot of times for that to happen. And if you were very careful, you could extend that lifetime. But this is not probably what's going to be happening. I mean, you're a lot of times people, if they get these for the first time, at least that's the way I'm feeling, you're more concerned about dealing with all of the dripping of the resin, and there's all these other things going on when you're taking this on and off. So your last thought is, oh, am I getting this perfectly aligned so it's not going to cross thread my aluminum thread mechanism on the nut portion, what would be the nut. They would have been better off getting a stainless steel nut as an insert to put into the aluminum and mount that into the part, and then have the stainless steel screw. That way it would last much longer. That would have been a much better choice. Also, this doesn't necessarily, comparatively on the Peopoly, this doesn't have that key feature. It basically uses the fact that it has a slot that only goes so far. It has a radius which matches the screw of the mechanism that holds it in place, that stops it from moving around. You can see this one's also a stainless steel screw, or it's at least steel. The other thing is, this is steel that it mounts onto. So you have two materials that are very robust that it's screwing in and out of over and over. So the likelihood of this lasting much longer, much higher than this setup with these material choices. And that key feature, like I said, of getting this on so it's right in the right place. This one's key featured by the two sides. This mechanism holding it so it's not going to go side to side, and then when you do the friction by screwing this down, and then the pressure of tightening this down prevents it from moving forward and backwards. Very simple, really robust, like I said. So obviously in this area, I feel that the Peopoly is far and away better. So it's clear to see the Peopoly beats out the T1000 as far as size of the build plate. This build plate, another issue that I have with it is, well, issue with this one rather, this build plate only has 4 screws into the top of this aluminum build plate, and the holes don't go through to the other side. So you have this perfectly even surface here. This build plate is made out of 3 different pieces. You have this some sort of plasticky something that has 6 screws. So obviously your build area is inside of where those screws are. Second, this top piece is screwed to this piece by 4 screws that are underneath this. So to get to them, I'd have to take these 6 screws off, and then I could get to the 4 screws to hold this on. And additionally to the 6 screws that hold this plastic piece here, there are 2 screws that hold the piece here. Why does that matter? First off, this is a really, looks like to me, a Band-Aid cobbled together engineering nightmare of we wanted this and then we decided we wanted something else, so we did something else, and instead of going back and starting at the design process at the beginning and fixing some of these issues and making it one homogeneous design, they just left all of these Band-Aid fixes in. That's the way it appears to me, but maybe they did intend it for it to be all this way because they really like this material. But anyway, the main problem that I have, I had to get a second build plate during all of those earlier machines because I had something go wrong with the build plate, or there was a gouge in it. So when I got the second build plate, like this mechanism, this piece on the top was all wiggly, and I'm like, okay, I need to tighten that. How do I get that? Oh, I have to take out these two screws, I have to take out these screws, and then I have to screw this together. Which leads me to, that was a pain, and it was annoying, but the quality mindset at G3D may not be quite what is expected. Or at least doesn't live up to my expectations. I would expect that I pull a part out of the box, it's ready to put on the car, or ready to put on the machine. So in a car analogy, if I pull out some brake pads, I don't expect to glue the pad part to the metal part to put the pad into the bracket. I expect that that part's already done. I just need to plug it into the bracket and then bolt it back onto the car, right? Same thing here. I expect to pull out a build plate and be able to use it. I don't expect to have to disassemble it and put it back together so I can use it. So that was one frustration. The second one is, as I'm talking, you can see that there's getting to be this glistening, and I'm moving it around, and you can see inside there's a resin coming out. There's all these holes all the way through this thing, and there's a giant seam all the way around this, and no matter how tight you get it, when it submerges into the resin gets in between this plate and this plate. And then, furthermore, it fills up into these holes, and it gets in there, and then, so when you go to clean this up, you are forced to disassemble the thing just to clean it up. So if you want to move on to another resin, and you're concerned about mixing resins, or if you're just not going to use the machine for a while, and you want to make sure that it's all cleaned up, so if it does get somehow UV, somebody leaves the door open or whatever, you don't want cured UV or resin on the part, you want to clean it up, it's a nightmare to clean it up. So that is another negative for that. Anyway, so it's time to put some resin. Oh, there was one other thing that I wanted to talk about, and that is the failure I had between machine 2 and this machine, which the print started printing, and then I went to bed, and I expected my print to be done in the morning. Nobody does that, right? Because, you know, we get prints that are over 24 hours long. Of course, you are not sitting here babysitting the machine every single step of the way. But what happened was the machine got stuck in this loop where it printed the layer, it separated the layer, but then the build plate didn't move up in the Z-axis at all. It just stayed there. And then it tipped back, and then it printed the same layer over and over and over. So, for example, as a calibration mechanism, I have been printing these cubes that I made that are 20 by 20 by 20, so I can test and check the X-axis, the Y-axis, and then of course the Z-axis, and see what percentage of accuracy I'm getting out of the part, because the earlier machine, that was a huge issue. I was not getting the accuracy I needed. So I was basically printing another one of these, but I added a bigger resolution to see if that percentage carried across into a bigger number. So this was a 30 by 30. Well, you can see it's got 30 in the X and 30 in the Y, but it's got like 50. Well, maybe not 50, but it's got 40 at least in the Z. But this was supposed to stop somewhere down here, but it kept printing and printing. So what happened was it pried the coupler from the stepper motor to the ball screw here, and it basically separated the coupler. It broke the coupler. So that wasn't a good morning for me to wake up to. My $2,000 printer, and now I have this coupler that doesn't, that's disconnected. So I ordered, and then this of course was right after the COVID thing, so everywhere was shut down. These guys, while I could talk to them on the phone, their warehouses were closed. They couldn't ship me a new machine right away, blah, blah, blah. So I got on Amazon, I found another coupler, I brought it in, I installed it, and then the very next print failed, and I discovered the reason it failed is because when it was building up, it also bent the screw. So since the screw was bent, they needed to replace the machine. So I did get a new machine, and this one's been printing okay, or it's been printing fine. I've only printed like 6 things, and then this guy showed up. I printed a half a dozen things on that, and we'll get into that later. But it led me into a little bit more research into, or not research, but investigation of the machine, of how they were built and the differences. So I just want to go over those real quick. And sorry for the run and gun style shooting I'm going to have here, which is me hand holding the camera. But you can see this is a single rail. It's got the screw here, and you can see how much wiggle there is in there. Look at that. And the reason that is there is nothing holding the top other than this piece of sheet metal and a hole in it, and that's what's guiding it. But it has a lot of room that it can move. And so what that, and also since the screw is out in front of the rail, that means this guy has a lot of play. If I put the build plate back on, you can see that that build plate ends up with a lot of play. I don't know if you can see how much that is, but there's a lot of wiggle in this, in the relationship between the build plate and the vat there. And why is that a problem? Well, you can imagine the variety of problems, but it's exacerbated by this machine because the way that it separates the vat from the build plate by dipping, and you'll see this later, the vat actually dips away and peels away from this and then lifts the build plate on the Z-axis. So because of that, it's constantly pulling this away in this way. So in my humble view, that is kind of a poor design choice from an engineering standpoint. Now contrast that to the Peopoly. The Peopoly has a dual rail system. You can also see the ball screw is in between those rails. It's buried inside, and you can see that it's much bigger. The other thing is you have the bearing system at the bottom, and you have a bearing system. You can't see it very well. Actually, let's tools, manual, we'll send it down a bit. Now you can see there is a bearing up here, and there is no wobble inside that screw at all. It is locked straight up and down. It's moving straight up and down, whereas this one has the ability to twist slightly because that screw's out front. It's a weaker screw, and the top is not secured in a way that's going to hold it in place. So that, in my view, is also a problem. So let me put the camera back on the mount here. All right, sorry if it's all crooked. But anyway, so those are two issues that's an issue that I have between the two machines. You can see, you can probably guess my propensity is to give the Peopoly a win on the ball screw and rail system versus the T1000. So just as a recap, build plate, Peopoly. Build plate size, Peopoly. Build plate mechanism by attachment, Peopoly. Rail and confidence in, oh actually I need to put the resin in. Confidence in the rail system and the ball screw and the alignment, Peopoly. So anyway, there's not much resin left in this guy. So for the T1000, you pour in the resin just like you would any vat, but there is a don't fill over this line point. Now, as other people have said, there are issues if you even, like, here's the mark. I know you're not going to be able to see it, but there's a mark on this vat that says don't fill over this. This is the maximum, right? But if you fill up to the maximum before you put the build plate in, it's going to overflow because you have to account for the volume of the build plate. So I feel like there's a way that they could solve this by having a, two max line. Max with the build plate, without, so you know where to fill it. But you end up figuring it out anyway. There we go. So we're all set up here. There is also this funky mechanism by which you have to level or mate the vat to the system. So since I haven't printed with this in a while, I'm going to do this leveling process. Basically, you loosen up these screws. There is some pistons that go up and down on a screw, and there's this friction lever that is actually stopping the action of that piston going up and down. You loosen those so those pistons drive up into the build plate, or sorry, the vat, to press it against these tension mechanisms. So it's kind of like a big wonky thing, but that's what you do. I'm going to step behind the camera and go tell the build plate to go down to the bottom of the vat, so it will be in contact, and theoretically it'll be perpendicular to the entire face of the build plate and the bottom of the vat, so it's all together. So let me do that real quick. All right, so, and you could probably see this as a positive or negative. Using the computer to send information to this, I mean, it's kind of neat. If your Wi-Fi connection between the two fails, I don't know how you actually get this thing to work, but you don't have any buttons on this machine here to get the machine to do anything. You have to do it all from the web interface, which is fine. Now you can see, well, you may not be able to see, but I only put in that little bit of resin, and it wasn't to the full mark, but now that the build plate's gone down, it's just ever so slightly over the max line, but anyway, so it's all set. Now it's pushed the vat down slightly and forcing it into those pistons that are driving up, so I'm going to now lock those four pistons in place by turning up these friction levers. And once you do that, then now the piston can't go up and down, so now you can tighten down these four screws and force those into the top portion of the vat tray. So you can see this is kind of tedious, but you have some reliability of the leveling of the vat. Okay, that's all set up. So I'll show you the vat really quick. Here's one of the vats, replacement vat that I now will be using this one for just calibration and things like that. But basically it has these two rails here. The pistons are driving up from the bottom, and then those thumb screws that I was just screwing down are driving from the bottom. So those pistons are pushing up here. You lock out the lever so the piston can't go up and down, so the piston's at max height. And then you screw down these screws to push it against the piston. Now it's being pinched at four places, so the vat can't go up or down or start wobbling like this. So that's kind of the engineering thought behind how that design is working. So that's that one. This one's ready to print now, so I'm going to go back over to the computer and hit go, and you'll see it start printing. Actually, I'll leave this open so you can see that happening. Now you can hear the whining of that motor. It's driving this in down, peeling it away from here. So you pour all the resin in, and now you've got this suction issue that it is trying to overcome, and you can hear that motor really working hard. The next issue that you're going to see is, because I have a large build plate surface area coverage on this first layer, it's really going to be working hard to try and peel that away. And when I was on customer service with them, I kind of mentioned this to them and said, oh yeah, just help it by pushing down on this for the first couple layers. The first couple layers are going to get over-cured, so it really bonds to the build plate. So it might have a little bit of trouble in the beginning, is basically what he told me. From my personal opinion, I don't find that acceptable. If I'm going to, I shouldn't have to be here to babysit the machine to manually peel it away from the build plate for any of the layers. It should work. All right, sorry about that. My camera overheated, and it's probably going to overheat again. So anyway, I just wanted you to see this mechanism. You see how it's peeling away and dipping back up. That means that this is putting some force on that screw, which isn't good, in my opinion. So anyway, let's flip around here. We'll look at the Phenom process of me putting in the resin, all of that kind of stuff. I've already got some resin here. I shook it up a little bit. I've already got some resin in there, and it's suggested to use the plastic spatula to just kind of scrape across the film just so you can actually see the film. This allows some oxygenation to get in there, so you definitely get the build separation. I didn't have to do this on the previous, on the T1000 because I had already had it clean and there was no resin in it. So since this one has resin in it, I'm gonna go ahead and do that process. Next, we take the USB drive. Now this is kind of the negative without having the Wi-Fi enabled bit, but it's pretty easy. You put that in, go to print. Now I'm going to find my Mando 2 file. I'm going to tap that. You get a little display of what's happening right here, which it's again a positive. You have that right here, and all I have to do is hit play. It's going to send this guy down. Now this is where you've heard lots of people talk about this. The Phenom has this really loud fans that turn on. This does have the updated firmware. You can see the machine was on, those fans weren't on, so that is one positive about the update of the firmware. It's you're not hearing those fans constantly when you turn the machine on. It only has those on when it's going to be printing. So sorry if you can't hear me that well. That's just the nature of this beast. But once it gets down, now this one doesn't have that dipping motion. It actually lifts the build plate up and then brings it back down. To me, that makes a lot more sense. All right, so my camera overheated again. Sorry about that. So anyway, as I was saying with this vat and how it works with the film on the bottom, when you think about a trampoline, if you turn it upside down and the kids are jumping on it, and that shape that that trampoline makes as the pressure is hitting into the bottom of the trampoline, you can see like imagine the build plates on there, and as it pulls up, it kind of makes that shape of the, so it's really peeling all circumferentially around your part as it's pulling up, and it relieves the part. Whereas this one, you're only getting that leading edge and you're having to fight all the way across, so it has a little bit more pressure. Now this one is going along quite nicely now, but it's still doing this dipping action to pull the part off. However, I'm already starting to hear that it may or may not be working correctly. If for some reason I want to check this machine to see if the part is sticking to the plate, all I have to do is hit pause. After it finishes curing this particular layer that it's showing right here, which doesn't look very much, I don't know if you can see, but those are all support structure pieces. But after it's finished curing that layer, it's going to lift the plate high enough for me to be able to see what's on the build plate, which is awesome. Awesome feature. There's no feature like that for this one. So I can look under there and I go, yep, I've got all my parts, all my features are being built. It's stuck to the build plate. I hit play again, just resumes right where it left off. This guy, I have to look inside here and wait for it to dip, and then kind of look under here and see at the way, oh, it actually does look like it's sticking to the build plate. I get that brief second to check. Now, finally the build plate's high enough that it is not submerged in what I had there before, so I haven't even gone very long, maybe 30 minutes. So now's the time where I have to add more resin. So now I can fill up to that full point. Probably should put a glove on the other one, but I didn't get any resin on my hands, so I'm good there. Now if I want to fill up this, I actually don't even need to really do that on this guy because it holds 2 liters of resin with the build plate in it. So I could pre-fill this one as much as I wanted, but you can see it'd be just as easy for me to pour in more resin. So the capacity of the resin on this one is really low, and you have to be on top of it and fill it right away at the beginning. So that's a very minor negative, but you should be around at the beginning anyway because there's all this other funky stuff that you have to check into to make sure that you're not failing on your print. You have to make sure you're pushing down on this thing at the beginning if it's a big thing or whatever. So that's the getting things up and running and started. Another thing that I wanted to point out is at the end when I'm done and I want to pull this off, I'm going to do the run and gun version here again so you can see what I'm talking about. But if you look inside here, and I don't know that you'll be able to see, you can see the projector down there, but there's all these gaps around the sides here that go down into where the projector is. And if you guys know, if you're doing resin printing, drips of resin get everywhere if you're not super careful. Well, resins can get down into the electronics of this machine. This machine, nice solid surface all the way around. This is sealed down to the base because of the nuts here pushing it down. So if you get little drips of resin around here, super easy to clean up. I don't have any worries that my resin is going to sneak its way into the electronics compartment. So that's another kind of design choice that was made by the people at now I can't get the camera back in the right spot, but that's another design choice that these guys had to make because of their dipping action of the vat. So another kind of negative. And then the positive on this guy, again, you saw how I just hit pause. I could check the build as it was going. Super awesome feature. I imagine other 3D printers. These are the only 2 resin 3D print, only two 3D printers that I've ever used here at my house. I have used some FDM printers at work and whatnot, but for my money, having this screen here, it's telling me my progress here. My pause button, I can lift it up. It gives me all the information. This is going to finish in 4 hours and 19 minutes. It's been running for 34 minutes. All of that stuff, super awesome to have that right here. Only information I get to see from this at the machine is, yeah, nothing. So let's go over to the computer and kind of weasel my way through the shop here. This is the information that you can see on this guy. You can pause the machine here. You have to come over here to do that at your computer. So if your computer's not right next to the machine, it can be a hassle. This is the progress you see, and it's going to take another 3 hours. So I started the Peopoly one just slightly after the T1000, but the T1000 is going to take longer overall. This still has 4 hours to complete. This one only has 3. So there's a slight difference in how long it's going to take. I guess that's not really slight. That's like 33% more time for the Peopoly to finish. But let's see what the end result looks like. All right, while we're waiting for the prints to happen, I go over my little workflow print setup station. I built myself a table out of 2x4s and some MDF. This took me about 2 hours to build. It is 8 foot long because the MDF comes in 8x4, so it's 8 foot long and 2 foot wide. So I just split that MDF down the middle and made a top shelf and a bottom shelf, bolted them together, and then I put some plastic on the top and on the bottom shelf where the resin is going to be stored. As you can see, I've got all my resins down here. It's got a little bit of messy organization. I got some G3D, some cleaning supplies, some more plastic. Shout out to Uncle Jessy. These lunch trays are great for moving stuff around, keeping the mess located right there on your tray as opposed to dripping all over your shop. So this was a great idea. I even got the little Uncle Jessy pickle tray, the Korean pickled stuff, so I can clean stuff. This has just got water in it. Again, another shout out to Uncle Jessy. I got this ultrasonic cleaner, but I've got it filled with the super green or simple green or monster, what is it? Mean green, that's what it is, mean green solution. He's got a whole video that he is testing different cleaning solutions versus isopropyl alcohol. I still use isopropyl alcohol, but I don't use it as much as what most people would do. I put stuff into the simple green, or the mean green rather, and ultrasonic clean it for about 5 minutes. And then I pull it out of that and I just dip it into a bath of 99% isopropyl alcohol, which is hard to get right now. So good that I'm conserving on it, but anyway, just dip it in there for like maybe a minute or half a minute just to get the last bit of residue. Rinse it real quick in the water, and then I've got some rags here to dry it off real quick. And then I built myself my own UV curing station, which I have a part in here curing. Time to bring that out. But got just the reflective bubble tape, or bubble wrap rather, cardboard box, and obviously a UV light. And there's a turntable in there. So anyway, that's kind of my little station here. Got my gloves, spatulas galore everywhere. Yeah, so there you go. That's the new workstation. It keeps it nice and confined over to one side of my garage. I've got all my sewing machines over here, and then all of that kind of stuff. So anyway, there we go. That's the workstation. Let's look at some parts that I've made on both the Peopoly and on the T1000 previous parts before we review the parts that I'm trying to print right now. All right, so as I said earlier, I have made a few different things on both the Peopoly and on the T1000, and so we'll just take a look at a couple of these parts. One thing with the T1000 at the beginning, I didn't notice right off the bat, but when I started to make parts that needed to intersect with each other, or for lack of a better term, I needed to put together. So I had two different parts that were supposed to interact with each other, and they had specific mate functions. I was finding that they wouldn't quite mate correctly because there was some sort of error as far as the print size. I would go back to the SolidWorks model, I'd line them up, everything was perfect, and then when I'd print them, I couldn't print them together. And I don't understand, and I don't know why. Well, I guess I do know why, but I think that most of these companies that have you print a first test print when it comes out, they should actually be having you print something that's actually useful. Like for the Peopoly, for example, they are basically just trying to glorify the capability of the machine, which is great. I understand that. They have you print this cube, which I didn't even print it. But it has all of this matrix on the inside. You can check out some other people who have printed it. It is cool. It shows how fine detail you can get out of the machine. But other than that, it's not super useful. But what I did is I went in and I made a cube. A very simple cube. It's solid on all sides. It doesn't really have anything to do with that. But it has a little X and a little Y. And it also has a little Z. And it has a number on it. And this number indicates the size that the cube is. It's a 20 millimeter cube. So that means it's 20 in X, Y, and Z. So now I've printed this. I can go and I can take some calipers and I can measure it in X, Y, and Z and make sure that it's actually printing to the size that I want to print, and I can find out what shrinkage rate there is on the material. I mean, it's posted. Like, you can look at some of the resins will tell you it has low shrinkage. What does low mean? How low is low? But you can actually quantify that number of low. So this is actually, I've found to be a very useful test print versus just printing something. I'll show you the T1000's test print. Remember I told you I had 3 machines. I've tested it on 3 different machines. This is what you get a print from them. It's looks like a museum with some factory exhaust pipes out the back. I have no idea what this building is supposed to represent. But other than printing and saying, oh look, I can make something at whatever detail this is, I have no use for this. Unless I don't know, I had a 32:1 scale model of train set or something. I could paint this and use it on a train set. I don't know what you'd use this for. The thing that is interesting about this is I think almost every one of all 3 of these prints has some sort of failure in it or another. This one, for example, there's no dome on the top. Like, you can see one that actually printed the dome. It just stopped printing, and then there was crap on the bottom of the vat. So that one sucked. This one has most everything there. This little column, it didn't print where it connects into it. It like stopped printing, and then it somehow connected and kept printing. So that actually I just broke that column off. This one, it was missing all the columns in the front door area and there. So anyway, those were those test prints. I didn't even bother printing the test print from these guys from Peopoli, because when I found that issue with the T1000 where my parts weren't mating and I made this thing, I started printing these cubes to test. And so you can see I've got several iterations of this cube. I even have more. Hang on a second. All of these cubes, I did them at different sizes. Like, this is a 5mm cube. I have a 10mm cube, a 20mm cube. This is out of their clear resin. This is out of their black resin. This is out of the tough resin. This is out of the yellow resin. Remember, I already told you about the 20 and then the 30, and this broke the machine, and so I kind of gave up. So this is all out of the T1000. So I wanted to see if that percentage difference was at 5, 10, 20, 30, if it was the same number as I went up in larger and larger, which it seemed to be. The error was actually consistent. That's a positive, I guess you can. But the fact that X would be positive and Y would be negative percent difference, and Z was all over the place, it was really frustrating. So I had to go through and do some calibration activities on that machine, and here is one of what might be billed as a positive from the company, and that is the fact that, oh hey, actually I can get the little list here. Here is a XY resolution build volume chart that's on the side of the box. So I just cut the box off and I stuck this to the wall. But you can do any of these 3 different resolutions, and with their proprietary slice tool, you have to make sure that you're selecting the right one or you're going to get the wrong scale, all that kind of stuff. But you can see the build plate size gets much more, it gets much smaller basically. So, and then the volume obviously gets smaller, and the speed changes. So here we can do 35 minutes per inch. This you can only do 25 minutes, or this you can do 25 minutes per inch. So, all right, sorry guys, I have been using this GoPro that I just took out of the package that I've had laying around for a long time. I know this is gonna point to me being behind the times a little bit. It was a GoPro 7. I know they're on GoPro 8 now, but I don't have the latest greatest one. But now I'm back to my tried and true Session 6. I think the Hero 7, there's a problem with the battery. The battery is what's causing it to overheat, not the fact that it's running in this garage. It is kind of warm in the garage, but it shouldn't be overheating. But anyway, switching to a different camera, hopefully it doesn't cut out again. But as I was saying, the mechanism to change between these is a manual mechanism. It's in the back of the machine. I can't really show it to you right now because we're printing, but you have to take out these screws out of the back, then you turn a knob, and then you lift the camera, and then you move the knob into the next notch, and then you tighten it down. Well, each time you do that, you're changing the focus of the camera potentially. You're changing, obviously, how close it is to the vat, all that kind of stuff, which is why you get a smaller and smaller resolution, or not resolution, but smaller and smaller build area. All of those kind of things. So you have to end up recalibrating just about everything. So they give you this little square that's like 50 millimeters by 50 millimeters. They have a test file. You have to run that test file. It projects that image for a couple minutes instead of just like the normal minute and a half for the initial layers and blah, blah, blah. But it does that for quite some time, so you have time to make some adjustments. And you have to lay that in there and then make sure that it's focused so that it's all sharp lines and that it's the right size and blah, blah, blah. So changing between these is not you push a button and then you're somewhere. It's a fairly long setup time. Also, I've done it for a couple of the other ones, and I've had limited success. But to be fair, I've had limited success with all of these. And then talking to the tech that I talked to on the phone, he was like, it's always best to print on the 175. So based on that conversation, I'm like, well, why do you have these other three? Like, I guess if you really, really spent a lot of time, you could dial in one of these other ones, and maybe you were only going to use this one, and you weren't going to use the other ones often. So, or maybe their idea is that you buy 4 machines and you have one set on each. I don't know, but this setting, actually, you get fairly good prints if it does print. But anyway, that is something that isn't in the Phenom. You don't have the option to make this resolution change, or this this resolution change. So, and I don't necessarily think that it's a feature, but because that's built into it, there's all these mechanical bits that you have to fiddle with to make sure that you're getting the focus right and the size right. And I think it leads to my frustration that I'm having with having all these things be different resolutions. Like this one's off by like 5%, this one's off by 0.5% one way, and then 2% another way, and that's a huge variance between an X and a Y. Supremely frustrating. I thought maybe it was the material at first, so that's why I tried different materials, and when I finally got the third machine, after the third print, I finally got somewhere close to the resolution that or the accuracy that I thought would be okay to print some parts. One of the these are the best ones that I've had. You can see the previous version, you can see the 20. For some reason in the clear, the 20 doesn't come out. I don't know if you can see that. Might not even be focusing, but this one obviously doesn't. But this one is the most accurate as far as size, but it's not accurate as far as printing the parts. So, again, frustrating. The other thing is there's supposed to be an X and a Y and a Z. This is the very first print that I did out of the Phenom. It has the 20, it has the X, it has the Y, it has the Z. It has all of those features on it. So, and when I measured it, this is supposed to be 20 millimeters. It turned out to be 20.1 or less. 20.1 in one of the directions, and then the other direction it was 20.08, and then another one it was 20.07 or 9. I can't remember. But they were all, the key to that is the plus or minus was all within a very small window. So the standard deviation was very narrow, which is good, because that means if it was slightly off in one direction, it was almost exactly the same dimension off in all of the other directions. So proportionally, it was off equally. So that was good. The other thing that was great is it was very close anyway. It was within the acceptable thought of, if you had shrinkage or whatever in the material, it was within the tolerance that you would expect of working with some sort of polymer or plastic or whatever. So that was great. So that's the Phenom. So first one out of the box, printed great, so I started printing parts. Earlier when I first printed a part out of the T1000, this was the part, this was the mating part. These are supposed to connect in like this. They don't line up right because this one had a different shrinkage than this one, and it's annoying. I had to go back to my SolidWorks model and make sure that I didn't create something incorrectly, and in SolidWorks they all line up perfect. And of course when I print them, because of the different shrinkages or the resolution being off or whatever, very frustrating. And those were the issues that I had with the first machine, and that's why they sent me the second machine, and then that one broke because of the issue that I talked about earlier. And then the third machine showed up, and now I'd moved on to another project. But I did print, just out of curiosity, I printed those same parts out of the Peopoly machine with the Phenom and actually the Siraya Tech resin, and boom, the part fits. It lines up. It is supposed to be a pressure fit, so it's very tight. It came together. Here's the part by itself that fits onto this one. I could snap this together. It is a pressure fit, so it's a very tight fit, so it takes some force to put it together, but that was intended with the design. But it actually worked. So I moved on, and many of you know that I have an airplane. I was putting these GoPro 6, these Session 6s, on the dash of the airplane, and they would overheat, as you'd expect, because the windshield's right there, so it's sitting on the dash and it would get hot. So I decided to make a camera box to put them in and get some cooling fans to cool them. Well, this is the genesis of that. I know it looks kind of gross, but it will do the job. I glued some of that the same bubble wrap reflective stuff that I have on my curing station, but I glued it to the sides to reflect some of the heat. But there's a large fan. Actually, I can grab the fans. I need to put it back together, but here's some like CPU cooling fans that get mounted, donk, and then of course the cameras get mounted inside to the camera mount features, which I built in here, all that kind of stuff. It took me 4 tries to get this built out of the T1000, which was super frustrating. I had support structures inside here. These support structures didn't build, and then you can see there's a little, this is the best one, by the way. You can see that this didn't build quite right, but it built well enough that I can screw the fans on, so I was like, I'm kind of done rebuilding this over and over. The other side had the same issue. The support structures, for whatever reason, wouldn't print, or they printed halfway and stopped printing, and then all of a sudden it caught back up, and we got this, which is really interesting because you can see the layers, and the layers sagging. So that was kind of cool from the aspect of, oh wow, that looks neat, but what a bummer it didn't print correctly. So anyway, this was the one that I actually could work together. And then I have a lid that goes on it that's just supposed to simply drop on. It doesn't fit quite right, which has to do with that resolution and the accuracy of the print going in X and Y, but it will get in there. But anyway, there's this little lip here that goes inside the lip that I created here, and it kind of snapped in instead of just setting in the way that I wanted. Also, there were 2 features here. You can see there's only one that printed, the other one did not print. Yeah, so functional, able to use it, but I also have, if you look, I don't know if you can see these little striations, but the little lines that are coming up, and you expect that kind of stuff in a lot of these types of prints. There's a lot of holes where it didn't print. Anyway, like I said, was usable, and I went to the airplane and used it. It worked great, but when I got the Phenom, I was like, I want to reprint that same exact file and see how it works. This is the Phenom one. Oh my gosh, the thing, like the lid goes on, which is great. I got all of these are nice squares all the way around. The print, the support structures printed correctly. Everything about this printed correctly. This was the first one. That one took 4 or 5 prints to do. This one took one time out of the box, able to print. And as I said, this on the first print, it was within the accuracy that I would expect. So I expected this to print. This one I did spray paint. I spray painted the T1000 as well. So just because, yeah, it's going to be sitting in the dash, so it's obviously going to get exposed to UV over and over and over again. But this guy printed out of the T1000 very nicely and was much more up to my standard and expectations of the print. With that said, we'll wait for this print that we're doing now and see, first off, do the prints print or do they fail? And then if they do print, we'll evaluate those parts and see which ones printed better, and then we'll go from there. Anyway, see you guys soon. Quick status update here. We're not midway through, but, well, we should be about midway through on the T1000. We're about 35% through on the Phenom. One thing I wanted to point out here is because there's no display on the T1000, you have to rely on the web interface to actually see what's going on with the printer. Well, my computer lost connectivity with the printer, so I had to go back and reconnect Wi-Fi wise, and now this is all the information I get to see. Maybe I can click on this information. Nope, that's not a connect. I've tried all these printer page. Just gets to here. I can only pull out this drawer and see the status is printing. How long's left? I don't know. What layer is it on? I don't know. I don't know anything other than what that says. I have to come over to the printer, and all I know is, well, it still has some resin in there, and well, it's got something connected there. Looks like it's successfully printing. That's all I know. Whereas conversely, if I look at my Phenom printer, I have this display right here, and it tells me I'm 35% through. I have another 3 hours and 4 minutes to go. I've elapsed already 1 hour and 47 minutes. I'm on layer 269 of 764. Again, 35% through. And then I can also see that's the layer I'm printing. When it's printing, it's exposing, it's showing you what is being exposed. So I get all the information I want to know about my print and what's happening with it right here. Again, I can hit pause and lift the build plate and see, make sure it's all sticking to the build plate. Let's do that just for fun. We'll hit pause. It's gonna come down and then come back up. I don't even have to open this. I have this nice window here that I actually can see through, where this one I can't really see through that well. I have to open it to actually see what's going on. But this guy, oh man, my prints are looking beautiful. What's on there? So I can see that everything's there so far. See all those support structures under there and the actual print, some of the parts. Hit play. We're back in business, kids. We're printing away. So there's that. I will also point out on this printer, you do need to, because it's got a flat top, after it comes out of the bath and it's higher than the level of fluid, you should kind of scrape all this off, so when you do take off the build plate, it doesn't drip everywhere. This system has a taper on everything, so it should be technically running off. I do still find that I need to kind of help it along. It's resin is not quite as viscous as the other one, but that being said, the Phenom guys, the Peopoly guys rather, do have a new build plate that they are building that you can purchase at a discount, so you have a second build plate that actually has that tapered effect. They also have a 3D printed part that you can print yourself that creates that, but then you have that undercut, you know, the gap of of where it's going under, and the thing that I discussed with this guy. So anyway, the taper does help a little bit, but this, you just have to make sure that you kind of clean it off a little bit at the top before you take it off. Anyway, that's our mid-print check. We'll check back in after the prints are done. Woohoo! Hey guys, all right, so we're back. We've got our first builds are done. If we look in the T1000, it has completed its printing. We still have about another hour and 15 minutes on the Peopoly. So again, we knew this kind of going in, that this was a little bit slower printing. Has to do with it's an LCD screen and this is a projector, so this can you know, cure a little bit faster than this can. Also the chemistry of the resins play into that. All of those things. The layer heights were the same, so that should have been, well, they were very close to being the same. This one was 52.5 and this one was 50. But, I mean, that 0.025 is very small difference, so that shouldn't have played too much into it. Slightly, but that would mean that this one would have went a little bit faster because it was making bigger layers, so it was able to outpace this. But anyway, this will be done in about an hour. I'm going to go ahead and pull some of these parts off. Actually, I'll put some gloves on and I'll do it on the camera. I might high speed the camera, or the speed of the video, but anyway, we'll pull it off. That way you can see my process. Again, the Uncle Jessy idea here. Uncle Jessy, I've seen him do some of his stuff in his video. He just dumps them straight onto the build, or onto the lunch tray every once in a while. I like to just put a layer of paper towel here, just kind of mop up some of the stuff. First thing, I like to pull, without touching any of the resin, I like to not get any resin on this thing, so I'll pull the screw off first. And then let's get a spatula here. I'm going to scrape some of this off so it drips as much of the resin back into the vat as possible. Quite a bit of resin. I did scrape some of this off before. But as I said before, there's all these little areas, like it's pushing up out of this, the screw holes, and it's constantly getting everywhere. So that's a problem. And sorry about video earlier, just reviewing some of the clips and I had the news on in the background, constantly watching the COVID virus craziness. But anyway, alright, so there you have our part. I'm going to scrape a little bit more. Alright, so there you go. Got some parts there. I'm actually surprised. I thought that this was going to fail. I do see some little deformities in the print on one of the pieces already there, but I'll be able to evaluate that a little bit more later. So right now, I need to separate these from the build plate. Everybody has like a variety of spatulas. I like this little tiny spatula. I got this at Target, their XOO brand or OXO brand, whatever. This has been really great. So just get under one little corner and then it should separate. Oh wow, this really got on there. Anyway, once you get one little corner of this under there, then you can kind of start moving around it and pry it off. Alright, so right there, that is one really big chunk. It's 3 parts. The base support's kind of connected, so it made it easy to come off. I've got one more part to get off. You can see the dry areas, so obviously it had a really good mate. Alright. That guy came off quite nicely, so there's that part. Now, again, I try not to transfer resin onto this feature. Put that back in there. Now, this is what's great about the Uncle Jessy deal. I can just take this entire mess with me over to my cleaning station, which usually I don't have a bunch of crap in front of. And let's turn you guys over here so you can see what I'm doing. So now I can, a couple people, you know, some people put their parts directly into their cleaning. They're kind of at their little bit of their soft point right now. So now I find is a good time actually to take off some of the supports if you can. Like you can almost do it. You can almost. You actually can. I am doing it. Peel these off. So I find that I have a little bit less pock marks than I normally would, and since I'm not really paying attention to what I'm doing, I of course just broke this piece, but I might be able to glue it back together. That I'm not going to call a fault of the machine just yet. I mean, I could have had a crack in it before, but we'll evaluate that later. Anyway, so that part's off. And so I'll just take this part and I will drop him into my mean green solution. Same thing can happen with all these. The other reason that I like to take off all the supports now is because you can see a pretty intense lattice work of supports inside of this part. That means it's in between it, there is the surface tension of the resin is holding all the resin in together and it's pooled in there. And even if you ultrasonic clean it, it may stay in there. But if you take all the supports off now, you're actually going to be cleaning the surface of the part that you want clean. So it's better, I feel, to take it off early rather than after you go through the cleaning process. You've heard people do it in videos and they don't, either they're not aware that this is happening or they're not acknowledging it. They're like, oh, I cured this and oh, it feels like it needs a little more curing. Well, I believe that it's because they need to evaluate their curing mechanism or process up front, and if they did, they would find, oh, maybe I'm not curing it or cleaning it the best possible way. So that's why I take everything off. I get much better results. Everything is always clean after I go through this process. So anyway, I'm going to finish taking these apart. We'll look at these parts later after the Peopoly parts are done. All right, guys, look at that. Right at the end of our Peopoly Phenom printing process. It is lifting the build plate all the way to the top. Don't necessarily need to wait for it to get there. Wow, I got that thing on there tight. Anyway, pull this thing out. You know it's going to drip all over the place. Hold it over the drip mat here. Holy smokes, this thing is covered end to end. I don't know what tool to use here. All right. So you can see all the parts beautiful on there. I'm going to get these off the build plate, get them into the cleaning station, take off all the supports like I did with the T1000 parts. I will say I got one of these off before I cleaned it. I was a little frustrated. I broke this one. So this isn't the fault of the machine. It's kind of like a couple things. One, the material is super brittle. It's super tough, but also super brittle. So I was being a little aggressive and I chipped the part out. So part my fault, also part the fault of the fact that there are a bajillion supports under here. I let it do its auto support thing. The support density was probably a little too much. I probably could have gone back in and pulled that back a little bit. It made it a little bit easier on myself, so I'm going to call that a wash between my error and probably more my error actually. But the material is pretty brittle, so you have to be very careful. We'll see how this one is for me to take apart, and I'll let you know on that. So anyway, when I come back, yay, the fan turned off. Now you can hear me. When we come back, I'll have all these parts cleaned up. Probably won't do this one because it's broke. I don't see the benefit of spending the time separating this one. That one's going in the trash. But the other one did turn out. It's actually it's in here. Let's pull that guy out. It's not in here. I must have taken it out earlier. Yeah. Here is the little trigger guard. That one's in here. So that one's cleaned up. Just need to dry them off. And I'll clean up the rest of them. And I'll see you back in a few minutes. Woo! Alright guys. Finally the moment we've been all waiting for. I've got all the parts out of both machines. And I've cleaned them up. As far as taking off the supports on everything except for this guy. I kind of wanted to show you my findings on that. I already told you that I started to break it and I chipped it because this material is very brittle. So obviously we don't have an apples to apples comparison between the materials because they're obviously different materials. And that's kind of, I'm going to call one of the drawbacks of the T1000. You're kind of just stuck using their materials if you want to get the settings from what they recommend, even though, as I alluded to earlier, those settings may not be optimal and you have to still fiddle around and play with them. Meanwhile, with the Phenom, you can use a variety of materials. You don't have to use necessarily Pheopolis. I suspect and I gather from hints of conversations that I've heard on YouTube or had with myself, is that Pheopolis resin that they actually use is possibly, and I'm not 100% sure on this, but it's made by Siraya Tech. But you can go to Siraya Tech and order their materials. They have all the settings of their resins for Pheopolis on their website. Pheopolis also shares that on a web page. I think like a Google Docs you can download that has all the different settings for their materials, and they work. Like, I didn't change any of their settings that they suggested, and it works. The other great thing is that means you can get that material from wherever you want. This Siraya Tech Fast material, which is what I used here, I got on Amazon. I did call out to Matter Hackers, and shout out to those guys. They've been very helpful for me. Actually, that is where I purchased the Phenom from, which if you choose a Phenom, you can go to Matter Hackers, purchase from them. I will tell you there's a delay because of the COVID and all of that kind of stuff. I think if you purchase one now, you are delayed out until the end of June. So, and this, we're in the middle of May right now. So it's like 6 weeks before you'll get your machine. And so that's just the way it is. If you go with a T1000, they promise you'll have your tracking number within 3 days. They told me when I was at the booth at MD&M way back in the end of last year, they were like, yeah, you'll get it in 3 days. They said I'd get the machine in 3 days. I ended up getting it like a week later, 7 days, but that's because they're on a skeleton crew. And I will say this about those guys. Those guys are super nice. And they're awesome. They're just starting off their company. This is their first machine that they're putting out. So they have a lot of growth challenges that they're trying to go through right now, which I completely and totally recognize. All of that being said, let's get into what these parts ended up looking like. So as you recall, when I did the slicing, I was able to get a ton more on the Phenom because obviously it has a bigger build plate. So I was only able to get these 4 parts done on the T1000, and these are the same 4 parts that I did on the Phenom, but I was also able to get an additional 4 pieces to my project completed, all on the same build plate. Now, this finished an hour before this one did. And so you can say, oh wow, look, it's so much faster. But when you factor in the fact that it has a smaller build volume, to be able to accomplish what I did with a Phenom, I'd have to run this twice. So effectively, to get the result that I have here from the Phenom, I would have had to double the time that I ran this build plate. So effectively, the Phenom was faster because I was able to print the extra parts. So I would have spent another 3 hours, so it would have been 2 hours longer to replicate everything with the T1000. So that really shows you what the big deal is about having a bigger build plate. It's not only the fact that you can build a bigger part and you can start making bigger things, but if you're making smaller things, you can build more of them, so your benefits of the return as far as on time, you can see that the Phenom is gonna win out. Now, I will talk about a little bit about the removal of the build supports, because this material is really brittle. First off, I don't know if you can see this, but here on the supports, you can see that there's some flashing that merged like 3 of these supports together. That's a problem, because now I have this really solid chunky piece that is actually thicker than the thickness of my part. So when I'm going to start separating this, I'm going to transfer force into my part, and that's pretty much what happened here, and that's why the part broke. And to be honest, when I was doing this one, you can see I also chipped this one. So basically both these parts are useless, but part of that is my fault for not having reduced the number of supports, because this is way overkill on supports, let's just be honest. But it was the automatic support in Chichibox. I could have gone in and changed the density and fiddled around with that, and so that was on me kind of being on the rush. But at the same time, it's also a material issue, because this is very brittle and it shouldn't flash like that. Just for comparison's sake, these are the supports and how they are actually supposed to print, and this is how they printed out of the Peopoly. If you look at the size of the stems, you can see that this one printed those stems much bigger, which leads back to that conversation I was having earlier, how this is not as accurate as this and what you're expecting. So that means all the contact points that are attaching the support to the part are actually bigger than what you need, and so, like, yeah, it's a solid chunk. Getting this apart is absolutely a nightmare. It took me quite a while to get this one separated as well as I did. I did leave this one on here just to show you a quick kind of trick. Some people, you see this is what was on the build plate. It's no big deal. If you cut, you see how it cracked right across there? And then I can do another one over here. And now I've got a smaller chunk of the base that I have to deal with. So when I'm trying to separate the part, I can either separate it up here and get that small chunk off from the bottom and then start dealing with the supports, or I can just directly go to the part and start dealing with that. In this case, because I know how brittle this material is, I would actually try and separate this whole base first so I can start individually getting these bits off. So anyway, that's just kind of a little tip and trick that I kind of come up with. Break up the base so you can peel off sections of the base. But that's what I have to do with this guy. I did have to do it with these guys, so it made it easier for me to peel off, but I wanted to show you how much easier this is to actually peel off the support. I didn't take the support layer off of this one, but you can obviously see I can't just separate this part. It's going to snap my part. It's just too solid or hard. Look at this. I can just peel that off and the supports are gone, and there's few pop marks on the bottom, little zits as some people call them, and that's going to be easily sanded away. And actually the pop marks I took and I sanded some of them away on this guy. I don't know if this is focusing or not, but compare that to this one has not been sanded. You can see the little bit of pop marks, but this one's been sanded. But look at I didn't do any sanding, look at all the pop marks on the bottom of this, and look at how much work I'm going to have to do to clean that up. Plus, knowing that putting pressure on this is probably going to be catastrophic. If I put too much pressure on some of these faces, it's probably going to crack and break because it's very, very brittle. Sanding this is going to be no problem. I can just rub it on the sand. I actually started to sand this guy, and you can see there's still a little bit of light sanding that I still need to do, but a lot of those zip marks are gone. This is no sanding, so you can see that it didn't really have that much, which is great. Now compare the supports that I have to sand off on this versus the supports I have to sand off on this. You can see there's a lot less work that I'm going to have to do with this material. And for me to figure out how to get this material to work on the T1000 is going to be a pain. Possible to do it, and maybe I will, so I can have two machines running, but the other aspects of the T1000 with the way it peels from the build plate, you know, my confidence in its success of building a really good part is still low. If we look at the tops of the parts, you can still see the little bit of the layer striations, but this, it's so minor. It looks so beautiful. Like after I sand the underside here, which isn't going to be seen because this gets attached to a glove, so you're not even going to see the bottom part. That's why I chose to support that side anyway. This part to me is ready to paint. Whereas this part, you do see those layers. You possibly could paint it. I mean, it probably is similar, but I see there's little gouges where it didn't quite print properly, and it has some little sink spots. And then of course this side I'm gonna have to do a lot of prep work to finish that off. So anyway, that's those 4 pieces. Now again, I broke this piece trying to separate it. Again, that's partly my fault, but also it's indicative of this material being very, very brittle. Also, I wanted to point out there's a feature here, and I don't know if you can see it, but there's a little hole. It's an elliptical hole. It's rounded on both. It has a small, small radius on both sides. And then compare it to this one. It's obviously printed much, much cleaner on the Peopoly, on the Phenom. And obviously I didn't break it separating it. Even though I did that seam, it looked very violent the way I just like ripped this off. But I did that same process on this piece, and I had confidence that I wasn't going to break it. Whereas this piece, obviously it broke. I mean, so that piece is broken. This piece broke in the cleanup process. This piece broke in the cleanup process. And this piece, I mean, if you look closely at it, it didn't print as cleanly as this guy. You can see those sharp lines and those sharp corners. And this one, I can see that this distance from here to here is actually thicker than it on the same part from the Peopoly Phenom, which again goes back to my original major complaint with this machine, which is I don't feel that it is printing to the accuracy that you're thinking that it is. If you are printing miniatures and just a one-off thing that doesn't mate with something else and isn't fitting with something else, no problem. It's just a scale issue, and you may or may not even notice. But these parts that I'm printing, obviously this is the handle for a gun. This is for my Mandalorian Blaster, so this is going to have to fit to something else. And if all of them are a little bit fatter than what they're supposed to be, the features aren't going to fit into each other nice and cleanly. I did want to also point out, this was printed on the build plate flat like this. And look at this tiny, thin little outhang here. That is in the drawing. I haven't really looked deeply into this to see what that feature is for and how it connects into the gun. I will find out for sure when I'm putting this together, but that's a future me problem. But look how it printed. Like, it's there. I'm not sure that if I printed this on the T1000, if that would have printed this well, if at all. And definitely not with this right angle, even though it had some supports in here. You saw my problems that I had on my camera box. So I am going to have to give a win to the folks at Peopoli and their Phenom as far as like the print quality and the fact that you can use many different resins from other companies. Like I said earlier, I used one from Lacrete, which I don't even think that anybody else has really tried that on a Phenom. They are very expensive resins. That is another thing that I should bring up. And actually, I'll sidestep just a little bit and come back to these guys. I know it may sound like I'm really ragging hard on them. They are doing a great job for the first printer that they're putting out into the market. They're probably learning a lot. As I said, they are a very small group of folks. They, having put out just one machine, they do have a machine that will print, but it's so limited in some of the grander scheme of things, and that may not have been taken into account quite yet. So I hope they get the support they need from people purchasing this machine, using this machine, given its limitations, finding a niche where its limitations actually excel, so they can build upon that on their next iteration of their next machine. I do know that they are working on a larger format machine, so it has a bigger build volume. That contrasted by the folks at Peopoli, they've already got 3 other machines out there. They're different sized machines for their laser version, which is more targeted at the market of people that are competing against, say, Formlabs. Their Formlabs, Form 3 or whatever. We have one of those at work where I work, and I use that at work. But I still would say, even using that machine, the Formlabs versus this machine's is better. The print quality is as good or better than the Formlabs. The build volume is way bigger. The speed is way faster. All of those things. But that is a laser machine, so it's a slightly different technology. But my point is, Formlabs has a few machines out there and under their belt. So their next iteration of machines that they're coming out with are going to be better. And obviously, the Peopoli folks, they've had a few machines out there. This machine is awesome. The Noir is coming out. They actually announced it and the large version of the Phenom. The Phenom Large, which has also been released. However, if you go to Matter Hackers or all those places, they just say coming soon. There's no actual firm release date, and I think COVID has had something to do with that, and also development issues that happen everywhere else in all kinds of product launch issues. So I guess at the end of the day, what I'm saying is the Phenom actually met my personal expectations of what I should be getting out of an SLA, DLP, whatever printer, a resin-based printer with a LCD screen or a UV projection. Those are the two differences here. But this meets my expectation, whereas the T1000 is falling short on a variety of areas. One being the engineering, the choices that they use for materials, the choices they use or made rather with, for example, the ball and screw and the rail system and the dipping of the tank, all thinking outside the box and looking at a different way to do something, but fall short and cause other problems that haven't been fully fixed. So the machine doesn't quite work as well as what I had expected to. So there's that. And then again, their material cost. Going back to the material cost, I keep kind of going all over the place, but the material cost of these guys, it's like this particular material is their tough resin, and it costs $85 a liter. If you look at Formlabs, their material cost $180 or $179 or $175, something like that, a liter. And those two companies, you're kind of like stuck using their materials. Of course, you can use other materials, but you have to figure out ways to, settings and all that kind of stuff. In the Formlabs scenario, you're really stuck in their world because they have a proprietary bucket that the cartridge rather that goes in, so it fills, which is a nice feature. It auto fills, which Peopoly apparently is looking at building a add-on. And since the machine is modular, you can just order the kit and bolt it on, which is awesome. But it's basically a hopper to put the material in. Well, with Formlabs, you're stuck with that proprietary hopper system, and it has a little barcode, kind of like other, your desktop printer for paper. They have a little chip in there, so it plugs in and goes, oh, you're using the genuine thing, or oh, you're not using the genuine thing. So it kind of works against you a bit. But you're really stuck with the Formlabs. You could cut open the top and pour in other resin and then try and fool it, but then again, you're still trying to figure out how to make it work. Whereas, move even further back to the Peopoly, they're saying, hey, we make printers. If you want to use some other resins, go ahead and report back to us. We'll share that information, other people, other printers. And as you know, that there's a community of printer folks out there that are trying new things and sharing all that information, and they're all for that. So they recognize that, hey, we'll be really good at building printers, it feels to me, as opposed to, oh, we'll be really good at building a printer, we'll be really good at building the proprietary software so we can slice it, and then we're going to be really good at formulating the resins. I mean, that's just a lot of stuff that you need to be trying to take advantage, or trying to control, whereas the folks at G3D, they're trying to do all three of those things at the same time, launch a brand new company, first to the market, first marketed machine that they're putting out there. There's just a ton of stuff, and you have to recognize that that is a big hill to climb. So these guys are doing a great job trying to master all of those things and get out a product. However, it's just falling a hair short of what else is out there in the marketplace. So at the end of the day, I mean, I think it's probably pretty clear every step of the way that I've evaluated. It seems like Peopoly is way out ahead of the G3D, or out ahead at least of a measurable margin that it's easy to say that they're ahead, as opposed to there's areas where they're so neck and neck. I can't really think of a neck and neck area between them. I guess I can say that the T1000 over the Phenom, the T1000 looks pretty badass. It has some ergonomic design to it. We can go look at that really quick, I guess. I mean, they put some radiuses in the door, they made it look kind of cool, whereas this is just, it's a box with a window. The window looks great. They did do a really good job of keeping all the lines clean, so from a design aspect, that is pretty cool. I'm already printing another print job on this guy. They have to finish this blaster off, so I would like to see that Wi-Fi connection, but as you saw, the Wi-Fi connection actually worked against me when I was trying to figure out where I was in this print. Once the Wi-Fi connection got lost and I reestablished it, I couldn't get back to the page to tell me how much longer is the print, where is it at, and I couldn't get to the pause the print or stop the print or abort the print button. That was gone. The only way that I would have been able to stop the printer is to turn it off, and then, well, then you're definitely done. You just have to redo the print. So that is kind of a down feature. So I think I've beat this to death. I know this video is going to be probably pretty long. I've already done some of the assembly earlier while I was waiting for the print, so it's going to be over an hour. So if you made it this far, thank you so much for spending the time with me. This is a one-man show, one-man operation. I know some of the other people out there that do these videos, they've got a production crew and they've got a camera person and and I don't have any of that. I'm just all by myself here in my garage. So again, thanks for getting to the end of the video, and if you liked what I had to say, share the video. I think that's even more important than actually hitting the like button, but the hitting the like button is great. Subscribe. I am planning on trying to do more and more videos. I know I have a bunch of other videos on my stream here, or not stream, but in my library here that are more associated with math and things like that. But as I progress in my engineering career, it's going to be more about making things, maybe not cosplay blasters, but actually making things more like that camera mount and things like that. So keep checking back and hit that subscribe. Big shout out to Uncle Jessy. I've watched a bunch of his videos. I've learned a ton just watching his videos, so you should check him out. Also 3D Print Nerd, those guys, you should check those guys out. They have a lot of great videos and interviews and things like that. So there you go. See you on the next one.